everyone, this is Engineer Dario from Free Engineering Review Center. So in today's lesson, we will going to tackle about one topic in algebra. So for this binomial theorem, Pascal triangle, factoring, radicals, properties of roots, laws of exponents, and logarithm. So I think logarithm we will tackle it by the next day. So for now, I'm going to discuss about binomial theorem, factoring roots, radicals, and exponents. So okay guys, so welcome in Free Engineering Review Center. So this training you will learn the concept and theories involved in certain topics, and you will also know different strategies in solving problems, and simplified approach using reverse engineering methods, and advanced approach using your calculator, what you call as the calculator tricks and shortcuts, and other improvised calculation. So alright, so let's get started. The topic that I'm going to discuss is about binomial theorem. So we have here a certain brief description in its history. So binomial theorem is actually created by Isaac Newton. So one of my favorite scientists is Briosa. However, binomial theorem can be derived using the Pascal triangle. So Pascal triangle has been named to Blaise Pascal, that is a French mathematician. However, before Blaise Pascal created the Pascal triangle, there are also other mathematicians in an early age which has been already discovered. So in India, it is called as the staircase of Mount Meru. So in other countries, it is also called as Siam triangle, and in other countries as well, we have Yang Hu's triangle. So it's something unfair. Why Pascal triangle has been named to Blaise Pascal. So anyway, maybe I don't need to tackle with that. So what we are with is about the Pascal triangle. The Pascal triangle can be formed by adding the numbers above it. For example this one. So we have here 1, right? So at the top of the Pascal triangle we have 1. So if we imagine that we have zeros at its side, so therefore this will be 0 plus 1, that could be equal to 1. And 1 plus 0, imaginary 0, and that is also equal to 1. And so on. So the process is just copy this one, that, and 1. So 1 all in the right side, and 1 on, 1 in the left side. So same process, we have 1 plus 1, we have equals to 2, and 1 plus 2, that is equal to 3, 2 plus 1 equal to 3, and so on. 1 plus 3 equal to 4, 3 plus 3 equal to 6, 3 plus 1 equal to 4, and we have 1 plus 4, that is equal to 5, 4 plus 6 equal to 10, 6 plus 4 equal to 10, 4 plus 1 equal to 5, and copy the 1, and 1 plus 5, that is equal to 6, 5 plus 10, that is equal to 15, and we have 10 plus 10, that is equal to 20, 10 plus 15, that is, 10 plus 5 equals to 15, 5 plus 1 equal to 6, and copy the 1, and 1 plus 6 equal to 7, 6 plus 15 equal to 21, 15 plus 20, that's equal to 45, and so on and so forth. So that is how Pascal triangle is called. So however, there are also tricks or mathematical secrets that is embedded in a Pascal triangle. So let's discuss that. So here, Pascal triangle is really related to a binomial theorem by shown in the illustration. So considering the top one is the row 0, and this one is row 1, consider this is row 2, row 3, row 4, row 5, row 6, and row 7. So we all know that we have imaginary 0 on both sides. So therefore, if this is 0, this is row 0. This is 1, row 2, row 3, row 4, row 5, row 6, and row 7. So another hidden tricks in Pascal triangle is we can get the other series of numbers. For example, we have from 0, 1, 2, 3, 4, 5, 6, 7. The natural numbers. They're all natural numbers. So if we take the next diagonal of these numbers, for example, we have 1, 3, we have 6, we have 10, we have 15, and we have 21. Those numbers form a triangular number. So if we pile that one from top to bottom, it can form an equilateral triangle. Therefore, 1, 3, 6, 10, 15, and 21 is called as the triangular series. So if we take another series, we have 1, 4, we have 10, we have 20, and we have 35. 1, 4, 10, 20, and 35, that can form a tetragonal shape. Therefore, the 1, 4, 10, 20, and 35 is called as a tetragonal numbers. So on, so on, and so forth. So maybe you can also discover another terms since I have not mentioned this tutorial. So back to binomial theorem. So the number, the exponent here, that corresponds to the number of, or what row. What row. For example, this is row 0, so this will be 0. This is row 1, this will be 1. This is row 2, this will be 2. This is row 3, this will be 3. And so on and so forth. So if we expand that, that could be x plus y raised to the power of 0, that is equal to 1. So what is the good advantage, or what is the advantage of Pascal triangle, is we can easily get the coefficient of the binomial expansion. So this process is called as the binomial expansion. So therefore we have coefficient of 1. So therefore coefficient 0. If we take x plus y raised to the power of 1, we have coefficient 1, 1, we have 1 and 1. And we can have now x and y. So if we expand x plus y raised to the power of 2, for example, we have coefficient 1, 2, and 1. So therefore this could be 1, 2, then 1. You just need to type that one. Then you need to copy x, then raised to the power of 2. X exponent is decreasing while y is increasing. So example, this is x. Actually, this is xy, xy, xy. So since we have power of 2, so this is x squared, and y must start with 0. And we all know that y raised to the power of 0, that is equal to 1, so that is negligible. So we have x, so therefore the remaining is 1x squared, 1x squared. Then we have now the 2x and y. So this is decreasing, therefore this becomes 1, and from y equal to 0, next one is 1, so therefore x and 1, and so on. So we have 1, then we have x squared, so 1, then x raised to the power of 0, which is equal to 1, so that's why it's in 3 to 1. And we have from y 0, we have 1, then so on, and so on and so forth. We 1, 3, 3, 1, 1, 3, 3, 1. X is decreasing from 3 to 1, then Z, X raised to the power 0. And Y is increasing from Y raised to the power of 0, Y1, Y squared, and Y cubed. So, consider that that one. So, we'll know this is X, Y, X, Y. So, another concept in Pascal triangle that we can get aside from binomial expansion and sequence of numbers, we have the combination concept. That's why Pascal triangle or the binomial expansion can be used in combination concept and probability. So, for instance, we will going to take the row 6, 1, 6, 15, 20, 15, 6, and 1. So that is the row 6. So if we count the R term of what row the 3% the N, this is NCR. So on what row that will be the N, and the R can be found out of the sequence. So for example, this is 1, so that could be R equals 0. When R equals 1, that is 6 in row 6. When R equals 2, that is 15 in row 6. And when R equals 3, that is 20 in row 6. And so on with 4, that is 15, 5, 6, and 6, that is 1. So if you want to compute 6C3, that is row 6, so we need to take the row 6 here. Then at R equal 3, so I'm starting from 0, 1, 2, then 3. So therefore, 6C3 is equal to 20. So if you want to take 6C4, so that could be 0, 1, 2, 3, 4. That could be 15. If you want to take C5, it could be 0, 1, 2, 3, 4, 5. That could be 6. Okay. Alright. So that is the combination concept. Very amazing. So another concept here is in geometry. Yeah. So what we hear now, consider the previous one. I'm going to take the row 6 and also with the counting. So in the Pascal triangle, that is also related to geometry. Okay. So what we hear now here, 0, 1, 2, 3, 4, 5, and 6, that corresponds to the number of sides of certain regular polygon. So for example, if we have 0, that means none. Nothing. And if we have 1, that could be a point. Point is just one dot. And we have 2. So if we connect 2 points, for example, this is point A, this is point B, if we connect that one, we can form a line. Okay? That is a line. And we have 3, that could be a triangle. If we connect 3 points, 1, 2, then 3, therefore we can get a triangle. So, there. So, from 0, that is none, 2, 11, 3, triangle, 4, quadrilateral, 5 pentagon, and 6 is hexagon. So, here is the trick. So, what if the problem with us? So, this is Pascal triangle. So, under geometry. So, what if the problem with us? How many line segments can be formed by connecting can be formed in the figure given. In the figure given. That's it. So this is the figure. So the problem is how many line segments can be formed in this figure. Number 2. how many triangles can be formed in the given in the given figure. I think this is in the given figure. So what if that is the question? Considering that we can only make considering that we can only make one triangle by connecting 3 points at a time. Let's look at this one. Considering we can only make line C by connecting two points. So that's it. So how many line segments can be formed in the given figure? So in this problem, we can solve it using Pascal triangle. So solution is using Pascal triangle. So since the line segment is, since in the figure we have 1, 2, in the figure we have 1, 2, 3, 4, 5, and 6. We have 6 in the hexagon. We have 6 points. So I'm going to take this row 6. Yeah. So take row 6 since there are 6 points crosses in a circumference. So that's it. So we need to take. Now I'm going to compute how many line segments. So that is a line. So I'm going to take the secant plus r equal to. So this one 0, 1, 2. So therefore that will be 15. So thus we have 15 line segments. Yeah. So that would be the answer. So we have how many line segments? It's 2. So that could be 0, 1, and 2 can be formed when we have 6 points that crosses in a periphery. So therefore this is 6. So in 2 we have 15. That's it. So if we try to take using the Google SketchUp, so if we're going to use the Google SketchUp, I think we can have the same answer. So I'm going to use segment. So considering we need to connect these 2 points. So we have 1 segment, 2, 3, 4, 5, and 6. We have 6 segments in the outside. Next is I'm going to connect this one. 6, this will be 7. Okay. This will be 8. This will be 9. Right? 9. Next is, so I'm going to erase that one. 9. We have 9. Next is, we have 9. We have 10. We have we have 10, we have 11, and we have 12. Next is, we have 13, then we have 14, and what do I miss? 14, then we have 15. Yes. So therefore we have 15 line segments. So therefore we have 15 line segments. So what about if we are going to how many triangles can be formed in the given figure? So if you can use conventional, again, solution. I'm going to use Google Sketch. It's conventional. This will be conventional. So this will be the conventional solution. Yeah, pala. Oh, no. Next is how many triangles. So if you want to make a triangle, so this would be 1. We have 1. Next is we have 2. We have 3 and 4. We have 1, 2, 3, and 4. Next is this one. 4. We have 5. This one. We have 6. This one. We have 7. Then we have 8. This one. This one. Next is this one. We have 8, no? We have 1, 2, 3, 4. We have 8. Next is we have finished this one. So we have 9. This one 9. Then we have 10. This one. And we have 11. Then we have 11. It's so hard. Ulit. Again, we have 1. We have 2. We have 3. And we have 4. So we start here. Next is we have 5, this one. We have 6, we have 7, and 8. Okay. Next is we have 9. We already finished this one when we start here. So this is not included. So we will have this one. This one. We have 9. We have 10. And we have 11. And if we start here, so we cannot 8, 9, 10, 11. So we cannot use this one because when we start here, we get this triangle. So what we're going to start now is we have this one. So we have 11, we have 12, we have 13, and we have 14. And next, so we're going to start here. Since we use this one, we go to this one. So we have 11, 12, 13, 14. We have this one. 15, this one. We have 16, and we have 17. And now we have this one, 18, this one. We have included this earlier. So we have 18, we have 19, then we have 20. So I think we already finished this one. We start here. So I think this is the last triangle that we can make. So we have 20 triangles. Thus, we have 20 triangles. So now, using Pascal triangle is a lot easier. So if you go back here, so again we have 0, which is non-line segment, and a point line segment, and we have triangle. That corresponds to 20. So therefore, so in row 6, R3, thus we have 20 triangles. So that's it. So you can also solve the number of quadrilateral to be 15. And we have 6 pentagons that we can make, and we have 1 hexagon that we can make. So that is the Pascal triangle. So we have now the binomial formula that is involved in the binomial theorem. So the term involving YR, it is YR is equal to NCR, X N minus R, Y raised to the power of R. And we have the R term. So the R term is NCR. You just need to subtract minus 1 in R. So this could be minus 1, this could be minus 1, and this could be minus 1. And if you want to get the middle term, you just need to divide n divided by 2 plus 1. Okay. So this term is from the binomial expansion that we have here. It is x plus y raised to the power of 3. So that's it. Okay. So let's take an example here. Binomial example. consider we have here, so I'm just going to type in here, say, oops, consider x plus y raised to the power of 3, which is equal to x cubed plus 3x squared y plus 3x y squared plus y raised to the power of 2. So that is the expansion of the binomial theorem. One more thing, we can also get so how about if we consider this 2x minus, let's say, 5y raised to the power of 3. So what could be the value? So if we take the example here, in this expansion, we have example. No. Not this one. So if we consider this expansion, so how about this one? So here is the technique. You just need to let x be 2x and y be negative 5y. So if we have x here, that could be 2x, and we all know this is plus y, so therefore if we plus, because that will make x plus y raised to the power of 3. So if I substitute this one by 2x and this one by 5y, it could be equal to 2x minus 5y raised to the power of 3. And this is now the problem. Okay? So you just need to assume that x equal to x and y equal to negative 5y. Okay? So now, here is the trick. You just need to copy this one, and all you need is just to replace x by 2x. So let's say I'm going to replace this one by 2x, this one by 2x, this one by 2x, this one by 2x, and I'm going to replace this negative 5y into y. So I'm going to type in here negative 5y, negative 5y, we have negative 5y, and we have negative 5y. So that's it. So this is binomial expansion. So that's it. So now, we just need to simplify the terms. So this will become 2x cubed, so that would be 2 cubed. We have 8, so this will be 8x q plus we have 3 times 2 squared times negative 5. So therefore we get negative 60 x squared y, and plus we have 3 times 2 and we have negative 5 squared. Okay, so that will be positive 150. We have x and we have y squared, and we have negative 5 cube. So that would be negative 125 y to the power of cube. So that's it. So I'm just going to simplify it furthermore. So this become 8x cubed minus 60x squared y plus 150 xy squared minus 125 y cubed. Now this is the answer. So this is now the answer. So I just need to bold that one. Okay. Oh. Okay. Now, how about if the problem has multiple choices? So this will be a board exam technique. So in board exam, you'll know that problems has multiple choice. So how can you solve directly a certain problem by just using a multiple choice when the problem is about binomial expansion? So that could be easy. So for example, find the equivalent of what is let's say let's say span so expand 2x minus 5y raised to power 3. Let's say we have a, this is letter a. Let's say this would be let's say 64. Let's say this is 20. And for letter b, let's say we all know that that's in letter b. So it's just for presentation. Let's say this is it could be easy if we change this end to end. Then easily get the answer. So I'm going to change is the middle one, make it a little bit harder. Okay, for D, let's say this is 80. So this is 20. So what about the problem? It's this one, expand 2x minus 5y raised to power 3. So this could be easy using reverse engineering method. So using reverse engineering method, we can get the problem, the answer by just utilizing the multiple choice that is given. So with the help of a calculator, so this one, so we have calculator. So with the help of our calculator, so I'm just going to type in the problem in our calculator. So we have 2 alpha x minus 5 alpha y, that is raised to the power of 3. So take note, this is the problem. So we're just going to assume any value of x and y. If that value of x and y corresponds to the choices, then that could be the answer. For example, if I assume x is let's say 0.5 and y, let's say 0.2. So we all know the problem is this one. So what could be its value? So that's the issue. So to substitute the value of x and y directly in your calculator, you just need to use the function calc. So using the function calc, you press calc. So we are asked what is the value of x. So I say that it be 0.5 is equal, and what is the value of y? Let's say 0.2, and then press equal. So therefore we got 0. It's not a good value. So we'll change this one by 2. It's not a good value. Sorry. Okay, change that one. So x is 2 and y is 4. So we got negative 4096. 4,000. Oh. 4,000, negative 4,096. So now, what we're going to do is to utilize the given process. So I'm going to check first the letter A. So what could be its value when x is equal to and y equal 4. So what could be its value? So now I'm going to type that one. We have 8 alpha x cubed minus 64 alpha x squared. We have alpha y plus 120 alpha x alpha y squared minus 125 alpha y raised to the power of q. So we got now the problem. So I'm going to substitute the value of x, that is 2, at 2, and y equal 4. So therefore we got negative 5,120. So negative 5,120. So this value does not correspond to the problem. So therefore, this is a big no-no. So that could be wrong. So now let's try to check letter B in this instance. When x equal 4 equal 2 and y equal 4, so what could be the value? So I'm just going to modify the terms. We have 150 and we get here 60. That's it. Then press calculate. We have the value of 2 and we have the value of 4. That is negative 4096. So this value corresponds to the given value of the problem. So therefore, since they are equal, so this could be the right answer. Probably it could be the right answer. So again, to check the other two, so I'm going to type in here letter C, and x equal to and y equal 4. And what could be its value? So I just need to modify the terms. Right here, let's modify it to 200. And this one we have 60, we have 8. Then press again count. We have 2, and we get 4. And the answer is negative 2, 4, minus 6. And this is not equal to given choices, therefore this will be the answer. And we have now lastly, that is letter D. Let's try to check this one, but I know this is wrong. So we got now the correct answer. But let's try to check again. So let's modify. So we got 120, and we got here 80. And substitute the value of x and the value of y. And we got negative 53.76. Therefore, this is so that is reverse engineering method. So thus, the correct answer is letter. So that's it. How about if we going to use using calculator tricks? So I developed this technique by using the combination. So let's try to use I'm going to use mode 7. Mode 7 is just need to go to clip. Then you just need to type in the function of x. We all know that we have n, c, r. This x raised to power n minus r, and y raised to power of r. Right? And here we have this term. That formula, and we will going to use that. So to make that possible, the concept here is so in the function of x, we go to the function of x. We need to type in. We all know we are the problem. This is the problem is this one. So you get that one. So what I'm going to do is I'm going just to same procedure. We just need to let x 5y and equal x. So we just need to let the term here. We just need to let x equal to x, y equal negative 5y. So what we're going to type in here is this variable. Copy that one. So the n is 3. So I'm going to change this one by 3. And the r is we don't know. So what I'm going to do is to calculate the coefficient of this term. So I'm just going to type in x. Let's see, let's leave it muna. The x here, I'm going to substitute that one here, copy. I'm going to paste it one. And the y is we have this one. I'm going to copy it one. I'm going to paste it one. So now I'm going to just assume that x and y x equal y and it is equal to 1. Just need to make this x and y negligible. So we need to delete that one and delete this one. If they are equal to 1. So what we have now is we have 3cr, 2 raised to the power of n minus r, n is 3 from the expansion here. So we have 3cr, 2 raised to the power of 3 minus r, negative 5 raised to the power. So this will x will be in function of r. So therefore x equal r. So since in our calculator that is in function of x, I'm going to change r by x. This is by x. And this is by x. So I'm going to type it. So let's go to mode 7. Then we need to type 3 shift C alpha x. Don't forget to close this combination. Don't forget that one, or you will get wrong answer. Then, oh no. Sorry for that. Then we get 2 raised to the power of 3 minus this alpha x, and we got negative 5 raised to the power of alpha x. So that's it. Okay. So that could be now the term. So I'm going to press calc. Equal. So that equal. It would ask what is the value of start. Let's say 0. And the value n. Let's say 3. Could be 3, or that is the value of n. Okay. Oh no. 4. We have 4. N plus 1. The number of terms is n plus 1. So we get 4. Then press equal. Or I think we may type in 5. It's okay. And press equal. Step is 1. Step 1. This means interval. Either you want, example, it could be 0, then 1, then 2, then 3, then 4, then 5. Because that's how it works. Okay. So therefore, the answer will be this one. So we have now the table. So when 0, when x equal, and when function of x equal. So this is 0, and this one is 8. We have 1, that is negative 60. Win 2, that is 150. Win 3, that is, let's scroll it down. We have negative 125. 4, we get error. It is doesn't have any more. And we get 5 now. So that's it. So this one is really so the ideal value that must be equal to it. So therefore this is now the coefficient. So thus the coefficient are 1, we get 8, we get negative 60, we get positive 150, and we get negative 120. And we all know in the traces, here, so from the traces, we have this one. So the only thing, the only letter that corresponds with this coefficient is we have, we have 8, we have 60, we have 150, and we get negative. So thus the answer is this letter. So that is using mode table in solving binomial expansion. So now, in a problem, let's expand the So problem number 2. What if the problem would ask what term involves y squared in the expansion of C. So what term find the term that involves y squared in the expansion. So what if the problem would ask? So we all know the answer would be this one, negative 1, positive 150 x, y. So here in our solution is using conventional. Using conventional solution. So by using conventional solution, we get the formula that y raised to power of r equal mcr x raised to power of n minus r y raised to power of r. So that is the formula. So in the problem, you need to take r equal, right? No, so this is 2. We have y squared. So for y is equal to r is equal. So I'm going to substitute 2 in the equation. 2, we get this 2, this 2, and we have this. Now the value of n. So in for the problem here, we get n equal 3, or this one. So I'm going to type in here, we have 3, 3. Next is, we need to assume, we need to let x equal to 2y, and y would be negative 5y. So I'm going to change this one, copy, let's change this one, and this one, let's change this one. So this is now the final. So now we're going to do is to simplify the expression. So therefore we have y squared, and that could be equal to 3 c2. So I'm going to close that one. 3c2. Then I'm going to take first the coefficient 2 raised to the power of 3 minus 2. And times negative 5 raised to the power of 2. Then the coefficient will be x raised to the power of 3 minus 2 times the y raised to the power of 2. So that is how it works. So we have y squared, this could be 3c2 times 2 raised to the power of 1, that is 2, times negative 5 squared, times we have x, this one is equal to 1, and we have y squared. So that's it. So if we simplify furthermore, we have y squared, and it could be, if you get the small component, computing 3c2 times, sorry for that, 3c2 times 2 times negative 5 squared is 150. So therefore this is 150 x y squared. So we got y squared in the expression. Thus the answer will be 150 x y squared. So that's it. So from the previous example, this is the answer. So that is good. We have 150 xy squared. So how about this one? For problem number 3. So how about if we're going to ask find the, let's say, this one. Let's say the third term. Find the third term of the expansion of this one. It's 2x minus 5y equal 3. So find the third term. So using conventional solution, so that could be easy. So we all know the formula for the R term is just this one. So I'm going to copy this one. And so you just need to change this by R term. And you just need to subtract minus 1 here. And you just need to minus 1 here. Here's this one, minus 1. or this will become okay, leave it like that. Now, in the expansion for this one, so for this expansion, so for the problem, 2x minus 5y resolve 3 n equal 3, and we just need to assume that x equal 2x and y equal negative 5y. So that could be the value. So now let's going to solve the problem. I just need to substitute the value of this one. So the problem for third term, therefore, r is 3. So I'm going to type this one. Now, the third term, r is 3. We have 3. And n will be 3. We have n equal. So the problem is just simple. Just to make you aware with the concept in binomial expansion. And we get here x is 2x. Just need to copy that one. And y is negative 5y. So I'm just going to copy y. So we have now here the third term, 3c, 3c2. So I'm just going to simplify this term here. Therefore, we got here 2. So this is 3c2. 3 minus 2, that is 1. And this is 2. And again, simplify furthermore. We got just need to get this x here times x is square 1, and this one going to get that out. So this will be times y result. So therefore we have here the coefficient. So if going to simplify that furthermore, so that could be 3c2 times 2 times 5 resolve 2, that is 25. 25 times 5, and we get this x and we get this 1, and we get xy squared. So therefore the third term will be this one. We have again 150 xy. So that's it. So that is how to find the third term and the y term, the yr in the term involving yr in the binomial theorem. So how about the problem with us? Find the sum of OA patient. The function this one. So how about the problem is find the sum of the coefficient and the expansion 2x minus 5y resolved. So that's it. So it could be easier. So we all know that the value of say using conventional So since we already get the answer for that, this one is equal to this one. So we just need to sum this all. So the equation is 8 plus negative 60 plus 150 minus 125, and that could be equal to, so therefore we got 8 minus 60 plus 150 minus 125, therefore we have negative 27. So how about using alternative the shortcut? So the shortcut is to assume or let you just need to replace every variable by 1. So for instance, if we have here the expansion, this one, the expansion, you just need to change that x and y are all equal to 1. So just replace this by, so this could be equal to 2 times 1, and this one could be 5 times 1, or that could be equal to 2 minus 5 raised to the power of 3, and that is equal to negative 3 raised to the power of 3. And therefore, the sum of the coefficient will be this one. So we have negative 3 raised to the power of 3, and that is negative 27. So we get now same answer. So in our example, in this previous example, how about if the problem is this one? So find the constant term of the expansion, this one. How about if expansion is this one? What is the constant term? We cannot make a constant term if every term has variable. So let's take the variable. So what could be 2x minus 5 equal 3? What is the constant? So here is the solution. So using conventional solution, we just need to let x be 2x and y be negative 5, right? So we just need to take that one. So we all know in the expansion, we consider this one because this is under x plus y result. So therefore I'm just going to copy this one. So therefore this one would be equal to this one. Using this variable, let's replace the value of x by 2x by 2x by 2x and y by negative 5. So let's change this one by negative 5. So this one by negative 5, this one by negative 5, and this one by negative 5. So that's it. So let's simplify another more. So let's simplify the term. Therefore we got 8x cubed, and this one we got negative 2 times 2, that is 4. Is 5, that is negative 20. Therefore, this is negative 60x x squared. And this one will be, we have 5 and 5. So we have 5. So therefore we have 150. So this is 150x. And this one is negative 125. Okay, alright. So that is now expansion. So if we simplify furthermore, this will become just need to take this one and this one and this one and this one and this one. So this is now, so thus the constant term is negative 125. So how about using binomial formula? So what if we use the binomial formula? So you can use the R term or the Y term, but I prefer to use the Y term. For me, it's convenient using this R term. Yeah. So the goal is to make x raised to the power of 0 equal 1 and y raised to the power of 0 equal 1. So that's the goal. To make it, to have a constant term, right? So in the expansion, for this expansion, make this y the x1 to be equal to the n equal 3. Okay. I just need to take the r equal to equal to 3. So that my variable x, which is raised to the power of n minus r, will be equal to x raised to the power of 3 minus 3. And that could be 0. Since we have only x variable. So the goal is to make the x variable disappear. You just need to cancel that one. So we got r equal 3. So I'm going to type in here. This will be 3. And is 3. Oops, it's 3. 3. We get 3 and we get 3 and we get 3. And for the expansion, we all know that the expansion, we need to let x be, we need to let x so therefore this one will become this one. So we need to write in here and here. Right. Then we need to simplify furthermore. So this becomes copy this one. We have 3C3. We need to close that one. And I'm going to make this one. I'm going to go to the last. This could be equal to 7. Since this one is 0. And this one we have negative 5. And we need to simplify it furthermore. And, so we become 2 to the power of 0, that could be 1, right? It could be 1. Any variable 2 to the power of 0 is equals. And this one would be equal to 1. And we all know that 3C3 is also equal to 1. So this becomes 1. So therefore, what left behind here is negative 5 reciprocal, and that is equal to negative 120. So thus, a constant term is negative 120. So that's it. So that is how we're going to solve the constant term. And now, so another problem that needs us, let's say, common numbers this one. We have 6. So what if the problem would ask find the term involving x squared in the expansion of this one. How about the x term is the problem? So the issue here is we have no formula for x raised power of r, only y raised power of r exists. This is the formula, this is the issue. So what I'm going to do is to make use of this formula again. But I'm going to take this x part here because I'm going to make it. So that's the goal. That's our goal. So to make this goal possible, first is I'm going to again show this one. So we just need to let x from the expansion here, 2x and y be negative. So this will be negative. And we're going to substitute that in here. So we're going to copy that one. So this becomes 2x. Back. This becomes 3. The issue is what is the value of r. And so I'm going to simplify this again. So let's simplify this one. So this becomes just going to get out here. And again, this will be times x raised to the power of 3 minus 1. Right? So we have 2 times 3 raised to 3 minus r, and we have x that is raised to 3 minus r. So that's the goal. So this is the constant part. So I don't need that. Only thing I need is this one. Right. Get confused. Make it happen. Okay, so I'm just going to take this one. Copy that one. So I'm going to take only this one. So therefore, we get 3 minus r. That is equal to 2. Right? So from exponent rules that x raised to the power of a and x raised to the power of b. So we all know that the b a equal b. Right? If they are equal. That's right. So therefore r is 3 minus 2. So thus r equal 1. So again, let's go back here. Then let's substitute the term. So we get 2x. For x we get 2x. And for y we get negative 5. Then we get to value 1. This one. So this needs to substitute 1. This one 1. This one 1. And the n is we get 3. So this is 3. Since the expansion is this one. So we get these 3, this 3, and that's it. So let's simplify. So if you simplify that one, this becomes 2. This becomes negative 5. And again, let's simplify this one. So this becomes AC1 times 2. This becomes 4x squared and negative 5. So therefore, we got 3 shift C. 3 shift C2 times 4 times negative 5. And we get now negative 60. So therefore, we got negative 60x. So thus, the term involving x squared is negative 60x. So this is now the answer. So that is now the answer. So I think this is another problem here. So what if the problem asks find the coefficient of constant in the expansion of same problem of this one. So using conventional solution, we all know that this term is equal to, as we solved it earlier, we have solved it. So we just need to take the sum of coefficient. It could be 8 minus 60 plus 150 minus 125. So in that here, x this doesn't have coefficient, no? So this could be so 8, 16. So here this is the term, so therefore this is no coefficient. Note that negative 125 is constant term. And should coefficient should not be taken as coefficient. So because its coefficient is equal to 1. So what I'm going to do now is just to take 8, negative 60, and 150, and that is equal to 90. So 8 minus 60 plus 150. Therefore we get 80. So using alternative formula, the shortcut one, the only thing you need to do is just to copy this one, and you just need to subtract that by this coefficient here, and that should be raised power of 3, right? Or the formula would be, this is x plus y, x plus a is equal to n. The sum would be for x plus a raised to the power of n. The sum of coefficient would be x plus a raised to the power of 10 minus a raised to the power of n. And we need to replace variable by 1. So this is the formula. So let's use the formula. So we have this one, and I'm just going to substitute the value. So therefore this becomes so therefore this becomes 2, and this becomes negative 1, and this becomes here, this becomes negative 3, Therefore, we get negative 3 raised to the power of 3 minus negative 320. Therefore, we get 91. And therefore, the answer is 91. Thus, the sum of coefficient is 98. So I think that's it for binomial theorem. So I hope you will like the video. So if you like the video, kindly like and share and follow our free engineering review center so that everyone may know as well. So you may also visit and subscribe to our YouTube channel for you to be immediately updated with our future tutorials. So this is all for today's class. If you have questions and verification, just comment below. Or if you want any suggestion for me to deliver certain topic uh, for you, just comment below. And I think thank you. And that's it.